Hey everybody, welcome back to iHeartStats. Today we're in the third chunk of this course, and it's about something called inferential statistics. I don't want you to freak out about that or anything, but this is the chapter that is the toughest kind of wrap your mind around when you're talking about statistics. So I want you to just kind of focus today. I feel like one of those exercise people. I just need you to focus for 25 minutes. Not 25 minutes, just 10 minutes. And we're going to get you through this. If you can stick with us through this little piece of the course, the rest of it is smooth sailing. So let's try to work hard on this little piece of the course. And then once you get that down, you understand what we're doing there, you'll see that everything else that we do just flows really naturally from it. So if you have to take a little bit more time on this particular part of the course and go over it more than once, that's fine. Do it. And make yourself feel comfortable with it, and once you do, you'll see that it's really easy from this point forward. Okay? So hang with me today, and we're going to get you through there. All right. When we're talking about the topic of inferential statistics, we want to start with the ideas that derive just from your question. What is it that you want to answer? Do you want to know about the relationship between two variables? Do you think something causes something else? That's where you start. So you have two variables, or you have some relationship, or you have some piece of information, and you want to find out whether it's really true or not. Now, to answer that question, ideally, you could go out and find out by doing research on the entire population of things that might be involved. So if you want to know the average education level in the United States, one way you could do that is go and find out the education level of every single person in the United States, and then you could calculate a mean, and then you'd have the average educational level. Well, that's extremely impractical. So instead, what we do is we just ask some people what their education level is, and then we try to figure out whether or not that value that we got from asking those people is actually accurate in terms of representing what's in the entire population. So there's two concepts that are really important here. One is the population, and that's the everybody that's involved in the question that you're attacking. And then there's the sample, and that's the group that you've actually collected information from, where you've gotten your data. What we would really like is for that sample to perfectly represent what's in the population, okay? But that's not always going to happen. It might not be representative. If I go out and ask 100 people what their education level is across the United States, I might accidentally run into, because of where I am or just who I happen to ask, I might run into people who have unusually high levels of education, or I might, on the other hand, run into people who have unusually low levels of education. So I might end up with the wrong conclusion about what that education level in the United States is. Okay? Now I want to figure out whether or not I'm wrong when I make that calculation, okay, based on my sample. And that's really what statistics is all about. It's trying to figure out whether we're wrong or not when we make that calculation from our sample. Now, the problem is, of course, you can't just decide whether you're right or wrong. What you're really going to figure out is what the chances are that you're wrong, okay? So anytime I do this kind of research where I take a sample from a population, there's a chance that I'm going to be wrong, or I'm going to be really far off in my conclusion. And that's what I'm going to try to figure out. I'm going to try to figure out what the chances are. The beauty of statistics is never having to say you're sure, because there's always a chance that you're wrong. When you do this kind of research, you want to have a random sample of the entire population. So you want to figure out some way to get truly random cases from the population to represent your sample. The closer you get to that, the better off that you'll be. But even if you get them perfectly randomly selected, there's always a chance that by random chance, you're going to end up with some people that are higher than usual and people that are lower than usual. And if you get too many of the lows or too many of the highs just by random chance, then your conclusion's going to be off. That's what we're all about in statistics, is figuring out what the chances are that we're going to be wrong, okay? We're never going to be 100% sure that we're right. We're never going to be 100% sure that we're wrong, but we're going to figure out what the chances are that we're right or wrong. And we're going to try to minimize the chances that we're wrong.